Yes, so let's solve some problems on belt drives. Okay, in today's class, right? So what we know already over here is that, okay, so whether it's open belt drive or cross belt drive, the major thing first that we should know is that, so we have two pulleys having different diameters, okay, D1 and D2. So here, whether it's an open belt drive or a cross belt drive, okay. Now, say for example, if this is the driving pulley and this is the driven pulley. Now, if this bigger pulley is going to make one rotations, okay, then this smaller pulley is going to make more than one rotation because the radius or the diameter of this pulley is smaller when compared to this. So what we need over here is that what is the D1 diameter of the bigger pulley, what is the diameter of the smaller pulley represented by D1 and D2. Now how many rotations is this bigger pulley going to make? Okay, so one rotation for our example, so denoted by N1 at the driven driving end, okay, and number of rotations that the other pulley, that is the driven pulley, is going to do over here is denoted by N2, right? Okay, now these four things is what we require over here. Now as we have seen over here, if this bigger pulley makes one rotation, but what is going to happen over here, the smaller pulley has got a lesser diameter, so it is going to make more than one number of rotations. So actually this depends upon the diameter of the pulley, right? Okay, so thereby what we need over here is that this formula is going to come up over here, which is called as the velocity ratio, right? What is the rate at which the belt is going to transfer the power? What is the speed of the belt that is that is in moving condition, right? So for this we need these four data, which is N1, N2, D1 and D2. Out of these four we should have any three, so that we can find out the fourth one, right? Okay, so let us start solving the problem. Okay, so here we have a turbine runs a generator at 1200 rpm. Okay, the diameters of the turbine pulley and the generator pulley is 1.2 meters and zero point 0.4 meters respectively, right? Okay, so here what we have, there's a turbine. Okay, so let us assume there's a shaft over here, and once this turbine is going to rotate, this shaft is also going to rotate, and from here it is being connected to another pulley, okay, where there's one more shaft over here. For this shaft the generator is going to be connected, right? Okay, so the turbine is rotating at 1200 rpm, so this is going to become N1. Okay, so they're going to take it up in the other way, right? Anyway, whatever it is, right? So yes, so the turbine pulley and generator pulley are 1.2 meters and zero point 0.4 meters. Find the velocity ratio. Okay, so here what they have considered, let us see. Turbine is considered as the driver and the generator is considered as the driven one. Okay, so D1 and N1 is going to be the diameter and speed of the driver pulley, and D2 and N2 is going to be the speed of the driven pulley. That is nothing but the generator, right? So diameter of the turbine is 1.2 meters, okay, right? And yes, uh, and diameter of the generator is zero point 0.4 meters, right? Okay, a turbine runs a generator. A generator is running at what speed? So that is why they have taken it as N2. Generator is rotating. The shaft of this generator is rotating at 1200 rpm, nothing but N2 value, right? So that is why N2 they have taken. N1, what is the speed of the this turbine pulley rotating? What is the pulley that is connected to the turbine rotating at? N1 is not given, which is what we have to find out, right? So what is the formula? N2 by N1 is equal to D1 by D2, or you can also write it as N1 D1 is equal to N2 D2. Now substituting these, okay, we have 1200, which is the generator speed in RPM, right? diameter of the generator 0.4 meters, and diameter of the turbine 1.2 meters. So N1 is going to be 400 RPM. So that is the speed at which the turbine is rotating, right? The turbine shaft is rotating. Right? So what they've asked is the velocity ratio. They want the ratio. That means what we need. So what is the speed? That means what they're asking over here is that, okay. So as I've just shown you, if we have two pulleys over here, right? If this is going to rotate one time, then how many times is this going to rotate? So what is the ratio of these two pulleys is what they are asking. So we need to have N2 by N1 is the velocity ratio formula. So now we know speed of the generator 1200 RPM, and speed of the turbine that we just found out is 400 RPM. So it's going to be 1200 by 400 three times. So what is going to happen if the now here we have the turbine rotating at 400 RPM, right? And the generator is going to rotate at 1200 RPM. That means what? If this is going to go for one rotation, then this is going to go for three rotations. That is the velocity ratio, right? So let's see the next problem. Okay. Yes. In a belt drive system, right? In a belt drive system, power transmission, the driving pulley running at 1000 RPM and another pulley of 300 in diameter, right? Of 300 in diameter at 1520 RPM is what is the given data, right? Okay. Now what we are supposed to find out? We're supposed to find the diameter of the driving pulley. Now first let us identify what is being given. Okay, there's a belt drive system. They have not mentioned whether it's open belt drive or cross belt drive. Okay, let us not worry about it. Okay, right. So they're not given that. Right now, what have they given is about, okay, the driving pulley, right? Now we shall always take the driving pulley as N1 D1. Okay, right? Whether it's RPM or whether it is going to be the diameter. Okay, so this is going to be what 1000 RPM is nothing but N1, right? Drives another pulley. So this is going to drive. This means the driven end, which is going to receive this rotational moment. Okay, has a diameter of 300 So this is D2, and at RPM 1520. So this is going to be into. We have to find out what is D1, which is not given. So here it is, right? So just like that, N1 by N2 is equal to D1 by D2. Also we can write N1 by N2 be equal to D2 by D1. Also we can write. Okay. Or we can write it like this. Usually it is actually written like this, driven by driving. Okay. So one substituting here we have, okay, N2 is 1520, diameter of that is 300 okay, and the driving pulley has got a 1000 RPM. So we are going to get 456 is the diameter of the driving pulley. Okay, right? So this is also required if we want to transfer power at this particular speed and so many rotations. This is how we have to calculate. Okay, right. Okay, so let's go to the next problem. Okay, yes. So two pulleys are connected by a cross belt drive. Okay, so here they have mentioned it is cross belt drive. Right, velocity ratio VR is 3. That means what? N2 by N1 is 3. Driving pulley runs at 500 RPM, right? So this is going to be a driving pulley, right? So N1 okay, and has a diameter of 200 and 2400 400 mm. So this is going to be D1, right? Find the speed and diameter of the driven pulley, right? So we have so they're not given N2 D2, they're given velocity ratio. So velocity ratio, as you know, they're given PR is equal to 3 times. So that is nothing but N2 by N1 is nothing but 3 is to 1, right? So if the bigger pulley or the driving pulley makes one rotation, the driven pulley is going to make 3 rotations. Okay, right. So now with this, we shall go ahead. So we can find out this. So N2 by N1 is equal to D1 by D2, right? So N2 by N1 is nothing but 3 by 1, nothing but 3. D1 by D2. Out of this D1 by D2, we know D1, which is 240. So 2004, so 200 and, how much are they given? 200 and 2400 mm. Okay, mistake. It's actually 2400 mm. There's a printing mistake over here. Okay, right? So we can now find out D2 is going to be 800 mm is the diameter of this. Now coming back to this, we can find we have found out this. This is going to be 800 mm, which we just found out from here. Now we have to find out N2. Now go back to this velocity ratio equation only, right? So now we have N2, sorry, now what do we have? We now have N1, sorry, N1 also we don't have, N2, okay, N1, N2, then D1, D2, right? Now substitute this, the equation, right? N2 by N1 is equal to D1 by D2, right? So N2, we don't know, D1 they are given 500 mm, right? And N1 they are given 500 mm, sorry, 500 RPM. D1 is going to be 2400 mm. Sorry, there's a mistake here again. 2400 mm, and here it's going to be 800 mm. So now when we do this, we will get 1500 RPM pulley, right? Okay, so this is how we can find out the other one, right? Okay. Okay, yes, so we shall see one more problem. The sum of diameters of the two pulleys, okay, so connected by a cross belt drive is 1800 RPM. Okay, that means there are two pulleys. Anyway, it's far away. Now, as of now, diameter of this bigger pulley, diameter of this smaller pulley, D1 plus D2 is equal to this 1800 mm because they are telling sum of the diameters of the two pulleys. Diameter 1 plus diameter 2, summation of both the pulleys 1800 mm. If they run at 500 rpm and 1000 rpm respectively, find the diameter of each pulley. Right? We have to find out what is D1 value and D2 value. Right. So how do you go about? So we know N2 by N1 is equal to D1 by D2. So D1, okay, but we don't know what is D1 and D2. So we can go by velocity ratio, 1000 RPM and 500 RPM. So velocity ratio is going to be 2. That means if the driving pulley makes one rotation, the driven pulley makes 2 rotations. So N2 is equal to 2 times N1, right? Okay, and similarly, when we put the same thing, N2 by N1 is equal to D1 by D2 is equal to 2. So now equating this, we will get D1 is equal to 2 times D2, right? Okay, now what we need, so D1 is equal to 2 times D2. So what they have given is D1 plus D2 is equal to, what they have given is summation of two pulleys. D1 by D2 is equal to 1800 RPM. So D1 is equal to 2 times D2. Substitute this over here. So 2D2 plus D2 is equal to 1800. 3 times D2, 1008 is equal to 1800. So D2 is going to be 600 mm. Now with this, if this is going to be 600 mm, okay, then 1800 minus 600 mm, we'll get 1200 mm. That is the bigger diameter the diameter of the bigger pulley or the driven pulley, right? Right, so we'll just look here. So d1 is equal to 2 times d2. Yes, this way also we can go because we just had this equation over here. So we just found that d2 is equal to 600. So into 2 times 1200 mm, right? So that is how we can also find out the other diameter in this particular case. Let's see one more problem. Okay, this is a very small problem, right? So as of now, what we are seeing till now is about how to find out what is the rotational speed of the driven pulley or driving pulley, or we are finding out what is the diameter of the bigger pulley or the smaller pulley, either it's the driver end or at the driven end. Now we are not seeing what is the speed of the belt at all. Okay, now let us see how to find out the speed of the belt. Okay, now in this particular problem, what we have is a pulley of diameter 500 mm is driven by another pulley 750 diameter. Okay, and the two pulleys are connected by a leather belt. Okay, if the smaller pulley rotates at 150 rpm, find the speed of the larger pulley and also find the velocity of the belt in meters per minute. Right, now we have to find out the belt at what rate is it traveling, right? So d1 is going to be 750 mm, okay, and this is going to be the driven end, which is going to be d2 500 mm. Okay, and smaller pulley, which is the driven end usually. Okay, so it is got 150 rpm into 150 rpm. We have to find out the speed at the driven end n1. Also we have to find out what is the velocity of the belt. So n2 by n1 is equal to d1 by d2, right? So thereby n1 is what we have to is unknown. So once when we substitute these values, we'll get n1 is equal to, sorry, it should be here 100 rpm, not mm, because it is number of rotations the pulley is going to make. Okay, okay. Yes, so n1 is going to rotate at 100 rpm, n2 is going to rotate at 150 rpm. Right, now we have to find out the speed of the belt. Now anywhere that we measure onto this power transmission system in belt drives, the speed of the belt is going to be the same. So we can either take n1 or n2 value, either at the driven end or at the driving end. So V is equal to pi d1 pi d into n. That is the general formula. Divided by 60, we'll get it in minutes. Okay, so pi d1, so we'll take it at the n1 region, pi into d1 into n1 divided by 60, or that is also we can take it at the driven end also, no problem, right? So what pi, so then we have 500 mm, right, at the driven end, and into they want it in meters per minute, so meters per minute, but what we have here is in mm. So 500 into 10 power minus 3, we are converting mm into meters. Okay, and speed of n2 is 150 rpm rotations per minute, so no need to worry about that. Okay, now multiplying all these things, yes, we will get it in this value, right? So this is how we are going to find the speed of the belt. So the belt in this particular case is going to travel at 235.6 meters per minute, right? This is going to be the speed of the belt. Okay, right. Okay. So we'll stop here for today. We'll continue in the next class.